much about volumetric analysis. It is a procedure used to determine the concentration of a solution. Now, you are reacting to solutions, one with non-concentration and non-volume, but the other with non-volume but a non-concentration to that solution. So the way that you can determine a non-concentration, the only way that we talk about titrations of volumetric analysis. So after so, I've decided to write some sort of the question so that we can just understand this. The first question is this one. 25 centimeter cubic of sodium hydroxide solution. 25 centimeter cubic of sodium hydroxide solution was titrated with 0.1 molarity hydrochloric acid. The following results were obtained. When you look at this table, we have burette, final burette reading, we have initial burette reading, and we have volume of acid used. We have pilots, we have 1, 2, 3. Now, sometimes you can find this table is not filled. It's not filled here. Sorry for spelling because I'm not good in L and R. I'm sorry. Some of the table, you won't find anything at the end. Now you need to fill up by taking final minus initial, final minus initial, final minus initial, final minus initial, and then you fill up the table. Now from this table and the data from the question, it is where now you can determine the number of moles of hydrochloric acid, the molar concentration of the sodium monoxide solution, and the number of moles of sodium hydroxide. This is titration, and this is based to acid titration. But remember one thing, when base and acid are reacting, we must have the equation. And that is called the chemical balance equation for the reactions. And the reaction between acid solution and base solution, salt and water. The reactants are base and acid, but the products are salty and the water. But if carbonate is involved in the reaction, carbon dioxide gas also is given out as the product. So that is the concept you have to understand. And now from here, the reaction is between sodium hydroxide plus hydrochloric acid. The reaction is between hydrochloric acid plus sodium hydroxide. Remember something very important in your life. Remember to write the chemical formula for every compound. Now, hydrogen and chlorine, hydrogen is a monovalent element, and chlorine is a monovalent element. And that's why we have written nothing here. So now we have written HCl. Sodium is a monovalent element, and this hydroxide is a monovalent element. Now, and that's why we don't find any number. Now, to produce, we have said it is salt and the water. Remember, salt is the reaction between non-metal and a metal. It is simple now. This is a positive, this is negative. This is positive, this is negative. Positive and negative get together. Why? Like charges repel, and like charges attract each other. That is a principle. It's a law. And that's why sodium and chlorine get together and form sodium chloride as salt. Plus hydroxide plus hydrogen. Now we get water. Now the products are salt and water. Now from the equation now, it is now we can balance. How many number of hydrogens are here in the reactants? 2. And also here 2. How many number of sodium are here? We have 1, 1. Oxygen 1, 1. Now our equation is balanced. If now the equation is balanced, from the equation now we obtain what we call it Mohr ratio. Mohr ratio, we have number of acid, number of base, which now number of acid is 1, number of base is 1. 1 is written from the coefficient of sodium hydroxide mathematically, and the coefficient of HCl. The coefficient of HCl is 1, and the coefficient of sodium hydroxide is what? 1. That is why we say Na1, Nb1. This is number of acid, number of base. The second step after you have written that equation, you have to go back to your question. From the question, we have 25 centimeter cubic of sodium hydroxide. Sodium hydroxide is a base. Now we have 25 centimeter cubic was reacted with hydrochloric acid. That is volume of a base, which is equal to 25 centimeter cubic. But it was titrated with 0.1 molarity of hydrochloric acid. Now hydrochloric acid, we have molarity of acid. That is molarity of acid is equal to 0.1 molarity. Molarity is measured in terms of mole per decimeter cubic. That's why we represent by capital letter M. Are you together? Now, if that is the case, from the table, it is where we can determine the volume of acid by calculating the average of the volume of acid used, except the pilot one. Why do we not include the pilot? It is simple now. We don't include because it is a trial. So, finding the average of the acid used, the average of the volume used is calculated by taking the average of the how many times have you gone when you are doing experiments. And that's why average of the acid used. We have average of acid used. The first one is 12.45 plus the second one is 12.50 plus the third one it is 12.55. You divide it by 3 because average is not something new. There is not something new that you can even imagine. Maybe where are you getting it? Average is sum over how many are they? Number of items. Now, calculating, definitely you find the volume of acid. That is what we are looking for. But the average volume of acid used is equal to volume of acid. Now, if you calculate and you divide, you find it is 12.50 centimeter cubic. Now, we have already the volume of acid, which is equal to 12.50 centimeter cubic. Now, after that, now these are what we term data of our question. These are what we call what have we been given from the question. Now the question to determine the number of mole of hydrochloric acid. Number of mole of hydrochloric acid. Remember, molarity is equal to number of mole over volume. Now, number of mole is equal to molarity times the volume. But make sure that volume that you're talking about here is written in terms of decimeter cubic. If now it is centimeter cubic, you convert it into decimeter cubic. By knowing that 1 decimeter cubic is equal to 1,000 centimeter cubic. Now, we are talking about hydrochloric acid here. Molarity of hydrochloric acid is given 0.1. Now, we have is equal now, molarity is 0.1 times volume of acid is equal to 12.50 centimeter cubic. But this is not a volume that we need. Why is it not a volume that we want? It is because it is written in terms of centimeter. So we need definitely to change into decimeter cubic. Why and how do we do it? We do it exactly by dividing by 1,000. Now, it is when you divide 12.50 by quantity, you get it is 0.0125. Now, let's multiply. Now, the answer, after multiplying this one, it is 0.00125. This is the number of mole. Now, number of mole, 0.00125 mole. Now, that was Roman 1. The number of mole of hydrochloric acid. The molar concentration of sodium hydroxide. When you talk about the molar concentration, we mean of molarity. So definitely here is to determine the molarity of the base. Now, what does we use from here? We use the concept known as MAVA. Molarity of acid times the volume of acid over molarity of base times the volume of base is equal to number of acid over number of base. There is nothing missing there except molarity of base. Now we make the subject of NB after closing multiplication. It is why now we say molarity of base is given as molarity of acid, volume of acid, number of base over volume of base times number of acid. Now let us substitute what will be given. Now molarity of acid is equal to 0.1. Volume of acid 12.50 times the number of base 1 over volume of base is 25 times 1. Now why we do not change those centimeter cube? Because it's the ratio of all of them. Now if now you keep on changing them, they will cancel. Now you keep on wasting your time. So save time and do as the year. Now what next here? You have this and this one, you divide by this one. Now the answer is equal to 0.05. Now molarity of base is equal now to 0.05. This is the molarity. This is what we term as molar concentration. Now the molar concentration determines them of finding out the molarity. And then next, the number of mole of sodium hydroxide solution. The number of mole of sodium hydroxide solution. It is from here now. Number of mole is equal to molarity times volume. Now remember, molarity is equal to 0.05 times the volume of a base. Because we're talking about sodium hydroxide, which is the base now. Volume is 25, but 25 is divided by 1000. Then you get it is 0.025. After multiplying now, you get it is 0.00125 more. Why are they equal? Have you seen here? They are equal. Because from the mole ratio, the number of acid is equal to the number of base. And that's why it seems to be number of mole. We have here and here. They are equal in magnitude because of their mole ratio that I've written it here. There is no table of value. It's now where you can think, where am I going to get this? Don't bother. It is something that exists. You have, from the question, you have mass. Mass of sodium carbonate. Remember something very important. Sodium is a monovalent element. Carbonate is a divalent radical. Now, writing the chemical formula, we write here by 2, by interchanging the variances. Now, the mass of sodium carbonate is given as 26.50 grams. Was dissolved in distilled water to make 500 centimeter cubic of solution. This gram was dissolved into volume of 500 cc. 26.50 grams was dissolved into 500 cc. This is where you can determine the concentration of the solution, sodium carbonate. Because dissolving grams in 2 volume is where you determine the concentration. We say the concentration determines by looking the number of the solute which are found in the solution. Now it is from here now you can determine the concentration of sodium carbonate, which is equal to mass over volume. But volume definitely is written in terms of decimeter cubic. Now it is where now you say mass is equal to 26.50 gram over volume is 500 cc. Now if now it is converted to decimeter cubic, we divide it by 1000. Now it becomes 0.40, 0.5. Now it is 26.5 over 0.5. Answer is 53. Now the concentration of sodium carbonate is given as 53 gram per decimeter cubic. Make sure that the concentration is written in terms of gram per decimeter. What is the aim of calculating the concentration of the sodium carbonate? Our aim is to determine the molarity. Now remember, we said molarity is equal now to concentration in gram per decimeter cubic over molar mass. Now which is equal now to 53 gram per decimeter cubic over molar mass of sodium carbonate. Molar mass of sodium carbonate, which now is equal to 46 cos 23 times 2 plus 12 plus 16 times 3, 48, which is equal to 106. It is the gram per mole. Now it is the 160 gram per mole. Now we are looking for the molarity. Now which is equal by 53 1 by 53 2. This is mole per decimeter. Mole per decimeter or cubic. Now molarity here is equal to 0.5 molarity. Now it is where now we say molarity of base is equal to 0.5. Now using the concentration, now we have determined the molarity of the sodium carbonate, which is the base. Now from the question, we have molarity of the base. But after we have made this solution of this concentration, we took 25 centimeter cubic. It is just like now you preparing juice. Now you have prepared a jug of juice with suitable concentration. Now you test and you think this is okay. I don't think if you can drink a whole jug. You take a cup or a glass, then you use it. The less you keep for the extra use. Maybe for your friends or for the other things that are available there. Or for the other people who are there. Now, after we have prepared the concentration, we took 25 centimeter cubic of the solution, reacted completely with. Now this is the volume of base. Volume of base is equal to 25 centimeter cubic. Volume of acid is equal to 20 centimeter cubic. Calculate the molarity of acid. The question is to calculate the molarity of what? Acid. But from here, we have this formula. Molarity of acid, volume of acid, over molarity of base, volume of base, is equal to number of acid over number of base. After we have written the formula, it's our task now to know the names of the formula. Do we have molarity of acid? No. Do we have volume of acid? Yes. Do we have volume of base? Yes. Do we have number of acid? They are not there. Do we have number of base? No. We have molarity of base? It is there. Now, we have to find the number of acid from the equation now. Now we're talking about the sulfuric acid and sodium carbonate. Now the reaction is between sulfuric acid plus sodium carbonate to produce salt of sodium sulfate. Why not sodium carbonate again? This is positive free, this is negative charge. They get together and form sodium sulfate. But sulfate is the valence. Plus, because carbonate is involved, carbon dioxide is also produced. Plus water. As I have said, the reaction between acid solution and base solution is all about producing salt and water. But if carbonate is involved in the reaction, carbon dioxide also is produced. Now, from there, it is why now we can balance our equation. Everything is okay. Now our equation is balanced. Now from the balanced chemical equation, we determine number of acid is equal to 1. Number of base is equal to 1. Now let us substitute. Now what is the need of the equation? Determine the molarity of acid. Now that is what is missing from this one. Now if that is the concept, let us make molarity of acid the subject of the formula. Now it is simple now. Molarity of acid is equal to molarity of base, volume of base, number of acid, over volume of acid, number of base. Now is equal now, molarity of acid you have got molarity of base 0.5 times volume of base 25 times 1 over 20 times 1 by 5 0.1 by 5 therefore. Now this time this one we get is equal to 2.5 over 4. Now we multiply, we divide. Molarity of acid is equal to 0.625 mole. Now in short, the molarity of acid, that's how we determine. This is the third question. It is to determine the relative atomic mass of the metal. Now the third question is 16 grams of metal carbonates. Now we have mass of metal carbonates is equal to 16 grams. Was dissolved into volume of 250. It is from here now we get a concentration which is equal to mass over volume. And the volume I said should be written in terms of decimeter cubic. Now mass is equal to 16 grams over volume 250 is equal to 0.25 decimeter cubic. 0.25. Now it is from there you get the concentration is equal now to 64 gram per decimeter cubic. Now in short, the concentration of X2 carbonates is equal to 64 gram per decimeter cubic. But now using this concentration, it is where now we can determine the molar mass. But we don't have molarity. Now it is our task now to find out the molarity. But remember, 20 centimeter cubic of the solution of this concentration was titrated against 0.80 molarity of hydrochloric acid. Now from this concentration, solution of this concentration, we have volume of base, which is equal to 20 centimeter cubic. Was titrated against of molarity of acid, which is equal to 0.8 molarity. And the following results were obtained, as you can see from the table. It is now the table was filled out. Now volume of acid from here, we take the average of these three readings. The volume, the average volume of acid is equal to 25.00. Then plus 25.05. Then plus 24.95. You divide it by what? By 3. After calculating, now the average volume we find it is 25.00. 0 centimeter cubic. This is the volume of acid. Now we have that volume of acid by taking the average of the volume of acid used, except the dry one. Now volume of acid is equal to 25 centimeter cubic. Now after that one, we have molarity of acid. We have said we have it. It's there. Molarity of acid is there. Volume of base is there. Volume of acid is there. Now from molarity of acid, volume of acid over molarity of base, volume of base is equal to number of acid over number of base. We don't have number of acid and number of base. Now we have to find this mole ratio from chemical balance equation. Now the reaction was between hydrochloric acid plus Hc2 carbonate to produce X chloride. This is a salt plus carbon dioxide plus water. That is the reaction. Because we are saying if carbonate is involved, there is a production of carbon dioxide. But if carbonate is not involved, it's only salt and water. Now from here we balance. Now here we have 2, then here 2. Now the equation, I think it is balanced. 2 hydrogen, 2 hydrogen. 2X, 2X. 2Cl, 2Cl. Oxygen 3, and then 3 oxygen. The equation is balanced. Now from here, we get number of acid is equal to 2. Number of base is equal to 1. It is now from MAVA. That is to say, molarity of acid, volume of acid over molarity of base, volume of base is equal to number of acid over number of base. Now from here, simple now, we are looking for the molarity of base. Now molarity of base is equal to molarity of acid, volume of acid, number of base over volume of base, number of acid. Now molarity of acid, it is 0.what? Times volume of acid is what? 25. Times number of base 1 over volume of base 20 times number of acid 2 by 2 1 by 2 0.4 5 5 then 5 4 0.5 times 5 0.4 times 5 is equal to what? 2 over 4. Now molarity of base is equal now to 0.5. But the question is not all about finding the molarity. We are looking for the relative atomic mass. By relative atomic mass definitely obtained when you have found what we call it molar mass. Now, from molarity is equal now to concentration over molar mass. Now, molar mass. Now, molar mass is equal to concentration over molarity. Now, molar is equal now to concentration over molar mass, over molarity. Concentration, we got it. Concentration was 64. Divide it by 0.5. Now, molar mass. Now, it is what? 128 grams per mole. Now, that is molar mass. Now, from there, we have X2 carbonates. It is molar mass is 128. Now, this is 2X plus 12 plus 48 is equal to 128. This is algebraic principle. Algebraic equation. Now, this is 2X plus, this is what? 60. Is equal to 208. Now it is 2X is equal to what? This one and this one, you have 68. Divide by 2, divide by 2. Now X is equal to 3, 4. Now the relative atomic mass of X is 34. Now, calculating the relative atomic mass, you find out the molarity. Because it is where now you can determine the molar mass. Because molarity is equal to concentration over molar mass. And molar mass is equal to concentration over molarity. That's what we do. Now let us see the other question. This is a subtopic, it is called determine the percentage of purity of a substance. There is something that you need to know here. There are two concentrations in the same reagent. Let us see. This is example number 4 we have said. Question number 4. A 5.125 gram sample of impure sodium carbonate. Impure sample. Impure what? Sample. Now we have to find out the concentration of impure sample. We have mass of impure sample. And the impure sample is sodium carbonate. Why? It contains some sort of impurity. Now we are looking for a purity. So we have to calculate the concentration of impure sample. In other words, we say it is a given concentration. There is given concentration and calculated concentration. Now, the given concentration, we call it a concentration of impure sample. Now, mass is 5.125 gram. It was dissolved into 250 centimeter cube. That is volume, which is equal to 250 centimeter cube. Now, we are looking for the concentration of impure sample, or we call it given concentration of sodium carbonate. Why do we call it given concentration? Because mass is there and volume is there. So everything is there about calculating the concentration. Now we calculate concentration of impure sample. Now it is all about taking mass over volume. Mass is 5.125 gram. Divided by volume. Divided by 1000, which is equal to 0.25 decimeter cubic. To 20.5 gram per decimeter cubic. Now this is called concentration of impure sample or given concentration. After that, you have to calculate the concentration of pure. You have to calculate the concentration of pure. That is called calculated concentration. Where do we get calculated concentration? Now, 25 of the solution were taken. The concentration of this one, they took 25. That is volume of base, which is equal to 25 centimeter cubic. Reacted with 35.8 centimeter cubic of 0.05 sulfuric acid. Now we have volume of acid 35.8 centimeter cubic. Then also we have molarity of acid, which is equal to 0.05 molarity. Now from this start is where we obtain the molarity of base. Using the general volumetric equation, we say general volumetric formula, mass over molarity of base, volume of base is equal to number of acid over number of base. Now, molarity of base can be calculated from this formula, but we don't have number of acid and number of base. Now, let us determine the number of acid and number of base by using the chemical balance equation. The reaction is between sodium carbonate plus sulfuric acid to produce sodium sulfate plus carbon dioxide plus water. Let's balance our equation. Is it balanced? Now the equation is balanced.
Yes.
Now from the balanced equation, we have a number of acid is equal to 1 number of pairs is equal to 1. Now from this equation or this formula, now let us determine the morality of pairs. Now, it is where we say morality of pairs is equal now to morality of acid, volume of acid times number of pairs over volume of base times number of acid. Now is equal morality of acid being given, it is 0.05 times volume of acid will be given 35.8 times the number of base 1 over now volume of base 20 times 1. The molarity of base is equal to 0.0716. Now if now molarity of base is equal now to 0.0716, we know molarity is equal to concentration in gram per decimeter cubic over molar mass. Now concentration after crossing multiply is equal to molarity times molar mass. Now molarity is equal to 0.0716 times molar mass. Molar mass of sodium carbonate. Because we're talking about base. Molar mass of sodium carbonate 106. Is it so? Now times 106. Then we multiply is equal now to 7.59 gram per decimeter cube. Now this is the concentration of pure sample. Now in short we have concentration of pure sample. Or in other way we say calculated concentration, which now is equal to 7.59 gram per decimeter cube. Why do we call it calculated? As you can see, we have obtained this concentration through all calculations. Now, if that is the case, how do we determine percentage of purity? Very simple now. Percentage of purity. Percentage of purity is equal to concentration of pure sample over concentration of impure sample multiplied by 100%. Or in other way we would have said given concentration over calculated concentration times 100%. Now from the question we got the given concentration was 20.5 gram per decimeter cubic. And the calculated concentration now we have got 7.59. That is to say 7.59 over 20.5 multiplied by 100% is equal to 37%. 37.02, which is approximately 37. Now the percentage of purity is equal to 37%. Sometimes you can be asked to determine the percentage of impurity. If now you have determined the percentage of purity, it is simple for you to determine the percentage of impurity. How? Because always percentage is 100%. Now, to obtain the percentage of impurity, you take 100% minus percentage of purity, which now is equal to 63. Now, percentage of impurity is 63%. That is how we determine the percentage of purity and percentage of impurity when talking about this volumetric analysis. So the most important test is to know how you can determine the concentration of impure sample. and how you can determine the concentration of pure sample. In short, we say we have given concentration because the mass is given. Calculated concentration because we calculate that concentration through calculations, through data. So we pass through different calculations until we get the pure concentration. So that is how we do. Now let us see the next part. Letani yoiki or auxiliary acid. Auxiliary acid, this is the symbol for auxiliary acid. But it is diluted, it is bound with water. Was made by dissolving 20.16 grams of the acid to make 1 liter. From here, you have the concentration of the auxiliary acid. Now the concentration is equal to mass over volume. Mass is equal to 20.16 grams. But from the concentration also, there is what we term as volume. Volume is 1 liter. 1 liter is equal to 1 deciliter cubic. Now this is also 1 deciliter cubic. Now here the concentration is equal to 20.16 grams per deciliter cubic. This is concentration of auxiliary acid. Now we have got the concentration of auxiliary acid. This solution of this concentration were calculated against the 20 centimeter cubic of sodium hydroxide. Now the reaction was between sodium hydroxide, which is base, and auxiliary acid. Now we have volume of base, which is equal to 20 centimeter cubic. And then we have molarity of acid, which is equal to 0.4. But from the equation now, we can determine, because the equation is there, the equation for the reaction is given. We can determine the number of acid, which is equal now to 1. And number of base is equal to 2. Now let us determine the volume of acid used. We cannot determine the volume of acid used without filling the table. Now filling the table, final minus initial. Here we have 26.50. Here we have 25.00. Here we have 25.00. Here we have 25.00. Now the average volume is 25, because we take 25 plus 25 plus 25, we divide by 3, because we are looking for the average. Now the volume of acid, it is 25.00 centimeter cubic. Now we need to calculate the molarity, so as we can calculate the molar mass. And after we have got the molar mass, what next is what to determine the number of molecules of water. Now from here, we use MAVA, and molarity of acid over volume of acid over molarity of base, volume of base, is equal to number of acid over number of base. Now molarity of acid is given as molarity of base, volume of base, times number of acid over volume of acid times number of base. Now substituting what we've been given from the question, molarity of base 0.4 times volume of base, which is equal to 20, times number of acid is 1, over volume of acid 25, number of base, which is equal to 2. Now by 2 here, 1, by 2, 0.2, by 5, 4, by 5 here, it is 5. Now you have 0.2 times 4, which now is equal to 0.8 over 5. Now the molarity of acid is equal to 0.16. Now from this molarity and concentration, we can determine the molar mass. Now from molarity is equal now to concentration in gram per mole over molar molar mass. Therefore, molar mass is equal now to concentration over molarity. Now concentration we have got it is 20.16 is equal now to 20.16 divided by molarity, which is equal to 0.16. Now molar mass is equal to 126 gram per mole. Why we have found what we call molar mass? We are not looking for the molar mass. We are looking for the number of molecules of water crystallization in the acid. Now from the formula here, this is the chemical formula. Now we have H2C2O4, then X, we have, this is what? Now this is equal to 126. After we have that molar mass, we have to write the chemical formula for the question. This means this is hydrated oxalic acid. It is hydrated oxalic acid. It is incorporated with water. It is bound with water. So we are looking for the number of molecules of water that were incorporated with oxalic acid. And that's why we say hydrogen, we have 2. Hydrogen is 1. 1 times 2. Relative molar mass of hydrogen plus molar mass, relative atomic mass of carbon, 12 times 2. Now plus relative atomic mass of oxygen, 16 times 4. Plus X in bracket, then X out of bracket. Hydrogen, 1 times 2. Plus oxygen, 16 is equal to 126. Now here it is 2 plus 24 plus 64 plus X in bracket 18, which is equal to 126. Now here, this one, 26. Then this is 90. Now this one, 26 plus 64. You get it? 90. Plus 18X is equal to 126. Now this is algebraic principle. Now it is from there, we have 18X plus 90 is equal to 126. Now we are looking for the value of X. Take now this to the other side. Now it is 18X is equal to 126 minus 90. Which now is equal to what? 60 plus 60. Now 18X is equal to 36. But by 18, but by 18. Now X is equal to 2. You understand? Now in short, the value of the number of molecules of water crystallization in the acid is what? 2. Now, in short, you would have written C2 and H2C2O4, then 2 water. That's over. Now, the most important thing is to determine the molarity. After you have got the molarity and the concentration is given, what next? You calculate the molar mass. After calculating the molar mass, you sum up what you've been given is equal to what you have got there. Then you come up with the algebraic equation, which definitely is simple for you to solve it. That is it, the end of volumetric analysis.